Hi. Oh, I'm shining today. My collector Mousepad and I just finished to prepare a new webinar about IEC 61850 for you. So let's start and see the results. Good morning and welcome to this new webinar about Panorama features. Today we are talking about power and especially about electrical facilities. The new standard IEC 61850, which is a specific topic from the energy sector. Our main business is Scada and HMI, so we ask for help to Niels from Brodersen, the Danish PLC and RTU manufacturer. As usual, I would like you to ask your questions all along the webinar and using the question mark button on the corner of the windows of the Webex window. And we will deal with them at the end of the presentation. And we also ask you our own questions through a poll survey while dealing with your questions at the end of the webinar. So welcome to Niels. Brodersen is with us today, which is represented by Niels Dilo Sorensen, as you can see on the picture, who is an expert on power and electricity. So I'll let you to present yourself.
Thanks, Julian. Hello, my name is Niels Dilo Sorensen and I'm the engineering manager at Brodersen, where I've been working for the last 12 years. My core responsibility is in the development of features and utility protocols needed by the industry, just like IEC 61850, OPC UA, PRP or HSR. But I'm also involved in helping people implementing their different projects utilizing our RTUs. Thanks, and back to you, Julian.
Thanks. As usual, François will deal with the demo involving PLC and Panorama to present us use cases with 61850. François is the first Panorama customer 30 years ago and became colleague in 1995. And I deal with the overall presentation as a Scada engineer. So for this webinar, we prepared a usual structure, a really short introductions of the company and their businesses, because most of you already know just one of us. So also we present the aim of the 61850. Then how it's designed and why it's designed like this. And it's a standardized solution, a norm, which answers to the specific requirement of the electricity sector. Then we will see the synergy between Panorama and 61850 and why we decided to use it natively the protocol part of the 61850. And also we are dealing with some features to illustrate the use within Panorama. So this will be the part of François. And of course, at the end, a short summary, a kind of reminder or rehearsal of the presentation. So let's talk about Brodersen's company and its business. I'll give you the lead, Niels.
Yes, well, as you can see from the slide, Brodersen was founded many years ago, and we have been a market-leading provider of remote telemetry units, RTUs, sensors and loggers, secure SCADA system and business optimization software, providing complete end-to-end automation and optimization solutions to clients around the world. For more than 15 years, our hardware and software products, system and consultancy services continue to be trusted by some of the world's leading companies across sectors such as water, electricity, oil and gas, infrastructure, transportation and renewable energy. Just back in 2017, we released our new RTU32 series, a complete new redesigned RTU platform based on modern technology with intelligent I/O modules, etc. We have offices all around the world, and currently we are located in Copenhagen, Denmark, which is our headquarters, London in the United Kingdom, Melbourne, Australia, Washington, DC in USA, and also in Seoul, South Korea. Our main industries are energy, water, rail, oil and gas, telecom, and also IoT. And the reason why we're able to be in all these industries is because of the versatility of our products. We support the protocols needed by the industries, just like with DMP3 for the water industry, IE 61850 and PRP and HHR in the energy sector, but also MQTT in the IoT world. So please visit our website for more details about the different features our products offers. Thanks, Julian, and back to you.
So I'm going on a short presentation of Scada, Panorama, and the Condra company. Condra is an historical software editor of a Scada system. The software was extended to a soft gateway telemetry tool and a distributed historian solution based on SQL Server. And we also deal with specific software development. Condra is living through 115 persons and generated a turnover of 70 million euros. Our first trend of Panorama is a software developer. I usually say when you ask a question, the right answer is in the office next door, because the guy who develops the feature is here in our offices, in our company. So the purpose of the Panorama software platform is the convergence into a single software of the fields and of the management side, the IT and the OT parts, and production, and of course all business of the industries. And this is for any automated facility, so it deals with water, building management, productions. And today we will focus on a real-time part, which is the software Panorama IEC, which you can see on the slide, is the center of our business. So this part is presented by the HMI side in the whole solutions, embedded features like trends, time maps, cybersecurity, redundancy, and dealing with several sectors, facility and sites. So as you can see, our customers' business and customers' activities cover a similar range to Brodersen's customers. And you may also find the 61850 in transportation, like battery management, some buildings like stadiums, airports, and specific industries like aluminium ore transformations and things like that. And of course, in the nuclear power plant sectors. So, Niels, it's you.
Yes, now let's have a look at why IEC 61850 is needed. Well, let's start with a small example. First of all, imagine having hundreds of manufacturing plants spread all around the country, and they all use different brands of communication devices, utilizing a wide range of different protocols. But in order to get these plants to work reliable and efficiently, they need to be able to communicate with each other. But it can be a hard job because of the different protocols, and not even feasible because the protocols are not interoperable. So now substitute the manufacturing plants with substation, and you have an idea what is happening around the world in relation to power transmission and distribution. And interoperability is only getting more important over the coming years because of the growing renewable energy sector, and it is also very important for developing a smart grid. So this demand for a common protocol that facilitates interoperability and communication between IDs in substation led to the IEC 61850 standards. So, but what do we then benefit from utilizing the IEC 61850? Well, the IEC 61850 standard was designed from scratch and with Ethernet as the communication backbone. making use of modern technologies just like VLANs and priority flags for goose messages and SMV sample measured values. It also utilizes a virtual object model of logical devices, logical nodes, and each data element is named using a descriptive string, compared to the old legacy protocols where normally it was a number representing the data. Furthermore, the standard also includes predefined object models for commonly used devices in the power industries, such as circuit breakers and switchgear, and also wind turbines. The object-oriented approach leads to a decrease in engineering cost as less time is spent on identifying the relevant points from the different devices in the substation, because the IEDs are self-describing. But we'll come back to that later. Client applications therefore no longer need to manually configure each point they need to access, because it can be retrieved directly from the device or imported from a configuration file. So therefore the cost on configuration and commissioning the IEC 61850 devices is reduced, because it doesn't require as much configuration as legacy devices. Now let's have a look at the network architecture. And as you can see, we have two types of network buses, all operating on the same Ethernet network. At the top you can see we have the status level, and this is where the Scada is located, but it could also be an HMI or other clients retrieving data from the IEDs. Secondly, we have the process bus level, which is where all the IEDs are, which can be transformers, wind turbines, relay circuit breakers, and sensors. At the process level bus, the IEDs are able to communicate with each other in a really fast and efficient way called goose messages. Therefore, the IEDs can react very fast if an error is detected in the network. Because they are programmable, they can even make some decision based on the signals derived from the other IEDs. So there's no need anymore for hardwiring important signals. But also, if some values are needed from a sensor across different IEDs, can just be retrieved directly from the network using the sample measured values. At the station level, the Scada retrieves information from the IEDs or even execute commands using the MMS protocol. The retrieval of the data can either be pulled or event-based using the predefined datasets in the IEDs. But IEC 61850 is not only a protocol standard seen from a communication perspective. It also includes a system configuration descriptive language, abbreviated SCL, which you might have heard before. It is a language or representation format for configuration of electrical substation devices. So let's have a quick overview of the idea behind this language. The idea is that you can have a file, the SSD file, system specification description, which contain a complete specification of a substation. Each IEDs defined in the system supply a configuration file which describes its capabilities. That is the ICD file, IED capability description. So, merging the information from the SSD file and the ICD files, you will end up with a file which describes the complete substation in detail. That is the SSD file, substation configuration description. And it describes all from communication like IP addresses, etc., ID capabilities, and the data types being used in the IEDs. So now it is actually possible to extract the configuration information for each IEDs and then import that either to a Scada client, an RTU, or put the configuration directly into the IDS itself. Yeah, so where do we, Brodersen, see an increased interest in the utilization of IEC 61850 in our RTUs? Well, a common scenario is when revamping a substation with PLCs or other devices which do not support the IEC 61850 protocol. Then the RTU can easily provide the needed data to the Scada host using either IEC 61850 OPC UA. It is just acting as a gateway for the Scada host. Another common scenario is also in new installations, but here the RTU is acting as a data concentrator because it collects data directly from many IDs using IEC 61850 or 6870. So it is acting as a repository for the Scada host so that it only needs to get the data from one endpoint, which is much easier to configure and maintain. So the RTU has all the needed information available. And as you can see, we support all the common utility protocols used in the industries, both new and legacy. And in which sectors do we see an increased demand for IEC 61850? Well, yes, in transportation, railway, metros, but of course also in power, especially in wind farms, but also in oil and gas. Why is people using an RTU? Well, because of its superior performance. It goes from 200 megahertz to almost 2 gigahertz quad-core processors. It has modern network connectivity, 1 gigabyte Ethernet, fiber optics, 4G connections, and also ADSL. It supports the modern network protocols like PRP, HSR, NIC bonding, and it has one configuration tool which is called the Work Suite, which is where we do all configuration, that is I/O configuration, application logics, and configuration of communications. But also because we take cybersecurity very important. The RTU has a built-in firewall. It supports signed application and encrypted storage. So that means that having a signed application, only the application that you sign are allowed to run in the RTU. The RTU is designed to be installed in harsh environments, has coded print, high isolation on I/O modules, etc. But one of the most important is the scalability of the RTU. It can be a low I/O count up to a really big system with redundant power supplies, redundant CPUs, and redundant I/O modules, for example, in SIL.
Thanks, Niels. The next step is to present the synergy between 61850 and Panorama. So the solution is independent, open, and is a tool based on those technical points, so the tree structure and object-oriented, using notification behavior, using features and services like discovery and exploration services, some buffering informations on-site and inside the acquisition part, and using standard configuration import and export tools. So I'm not especially talking about 61850 for this purpose, but also about Panorama with existing features and not especially developed for this purpose, but the mindset is the same, explaining the behavior of electrical installation, and at the end using this behavior, this template, structure in your Scada applications is the easiest way to handle the specification of the installation through the entire project, from one end to the other end. So you will exactly find the same information at the end in the Scada behavior as specified in your 61A50 approach. The native integration of the MMS protocol is obvious and logical, dealing with the exploration and importation services too. Up to build the core of the Scada application as many automated times as needed by the modes and by the life cycle of the real plant. So this integration ensures the complete compliance with all the features and services of the MMS protocol. We also made an import tool we will present to you in the demo, like we made the importation tool in BACnet, for example, to cover the exploration and import features that seems essential to us too. As we'll see, the entire project can be extended to the whole management of the facility and not only to 61850 parts. The first case I'd like to show you today is a common electrical management interaction. Several installations are linked together and need to federate their behavior. That's why we use 61850 for a power transformer or wind farm or for T&D. You may use several levels of management too. So on a local management for each facility, a gateway with a Brodersen device embedding a web server is a smallest solution. Or you can use a small independent Scada application that fits too. And of course, Panorama is able to handle all of this. But Panorama is really useful on a second level, dealing with a global approach for several plants, embedding all the interactions and the complete command together. So we use features like archiving, maintenance, on-call services, and a global maintenance for all the plants. And those up to the traditional higher level features for any distributed installations. So we provide also the reporting part to handle the life cycle of the installations. All those interactions can be built for each level of the system, and 61850 helps for that. But we will find this task, behavior, programmation on each level for each facility. So that's going to be a complex solution. So to avoid this, the useful idea is to federate all those splitted communications, control and management into a single digital structure, which can be named a global information system, a global industrial information system, and this brings consistency and simplification. The resulting information system based on the Panorama application has other benefits, other features like the access control, like its own network infrastructure monitoring capabilities, like using SNMP protocol, and sometimes plants are made of buildings with their own needs. Panorama is also used as a BMS, it's a building management system, to monitor consumptions, handle access control, etc. So you manage not only the 61850 parts inside Panorama, but also the power facility and all those operational needs. The second use case I'd like to present to you today is a process industry. The example is based on a hydrogen production. This is a high electricity consumption facility. So IEC 61850 becomes mandatory for this business. And also the MMS protocol is only a part of the whole Scada application. So it's a part of the process chain which needs some process features like the scheduling, storage database, emergency shutdown, traceability, and of course some power consumption in the building management system. And So all those behaviors can be handled into a single global Panorama application for the process industry. So we use slides to explain things, and now we are using softwares to show you how, but 2 slides remaining, so because the demo part needs some explanation. So in the first part, in the demo, we will deal with a Scada project to show you 2 ways of building your Scada applications. So the first one is the acquisition import. So it aims to replicate, to build a virtual terminal block inside the application while you are using the Panorama importation tool. And then you only need to pick the values and commands from and to the HMI layout, the HMI part. This gives you the opportunity to build a different navigation, layout, tree view on HMI side. So, and this is also a single and simple approach. The other approach is dealing with the smart Panorama features like automatic filling rules in your components. And this way you design components model you need using and containing the behavior, your Scada rules, your features like the user rights, the mimics, the archiving parameters, and then you declare in the same structure as in the PLC, and you add your components in the nodes. Thus, it will automatically link the data to the IID object, build the navigations, the archiving rules, the alarm systems, and all these things are regenerated inside your application just like you need. So it's a better approach to use Panorama software. The second part, the second demo, the other demo deals with a real customer application. So the purpose is to illustrate the 4 ways to send commands into the IID systems. As designed by the application engineer, sometimes the operator has to ask to the IID if we can send a particular command to the process. So exchanges are made, some information, the feedback from the IID is also handled by the HMI part to fit to the real IID behavior and to give information to the operator. So let's jump to the François share screen for this demo. François, it's your turn.
Hello, welcome to this IEC 61X50 demonstration. So today we're going to work with the Brodersen PLC that was provided by Brodersen with a program inside, very simple, just dedicated for our presentation today. It's currently filmed, and you can see live the image of this PLC, as you can see. And so you'll be able to witness exactly what happens on the RTU and what we see in Panorama. Here it's the Brodersen worksheet. That's the RTU program development tool. Just want to show you that this RTU program is very, very simple. We only have a few variables: analog input, Boolean inputs, and Boolean outputs. That's all we have. And remember the structure? That's the list of tags under the logical node called GGI.io, because we're going to see it identical very soon in Panorama. Okay, so now I switch to my English Windows virtual machine so that we can run an English copy of Panorama. I use the Panorama IEC import tool. I have configured it to scan the network on the IP address of the RTU, and I can press the IED discovery button. Now I can unfold the contents of the IED, and we can see we recognize exactly the list of tags we've just seen in Brodersen worksheet. So the next step is very simple. Click on the IED, it selects all the tags, and we click on the import button. So this has imported in the unit 1 of my demo application today. And let's open the application to see this import results. Okay, so it was imported here in unit 1, and the result of this import is the IED. It's created with the name corresponding to the IP address, so that you're sure to recognize it. It's created with a tree of objects corresponding to the logical device, the logical nodes, and the data object. So as I said, we have the same list as we've seen in the worksheet from Brodersen. If we have a closer look to one of the tags, we, for instance, see that analog input here has several child objects. Mag represents the value of the object, of the analog. Q would be the quality, and T the timestamp. Of course, this mag object has a value property in Panorama, which carries the timed and qualified value. So value has embedded the timestamp and the quality. These objects here are provided just in case the application wants an explicit access to the quality and timestamp. Okay, so as Julien has explained, we can use this set of objects as a big connector where the application can just collect the value it needs to animate the views, the alarms, and so on. And so you can use that here, keep this here, and create next to the physical device object your components or your objects that will receive the links from these properties and develop your application like this. In that case, your components that you instantiate here have no constraints on naming and organization. You just choose the organization you want. And you link their inputs and outputs to those properties. So that's the first methodology to work with IEC in Panorama. The second methodology is to use only the physical objects, the physical device object. It can also be imported by the discovery tool, because if you check only the top-level checkbox when you do the import, then you'll only have the physical object imported and not the tree or child object. And in that case, this plays the role of data server, like if you know Panorama, like the OPC client or the OPC UI client. And you can use this object as a source for external links, which means that you can then create components that can build the links from the structure of the components and maybe work a more traditional way for Panorama, and especially a way where your components will already embed whatever treatment like alarming or display that you want to do with the information. And so here, when you work this way, it means you don't have a big connector and the component. You just have the component, and the component builds the acquisition configuration, these external links, automatically from the structure. So if we go to the model, we have this logical node component, which is made of elementary data component. So I've got 3 elementary data components for this sample application, one for analog input, one for Boolean input, one for Boolean output. Here, the link is built, has been prepared to use the physical device property of the logical node component here, which means that when I have instantiated my component, I just have to configure this property IED Brodersen, so that the link will receive the value here. And that provides the first part of my external link. And the next part is only the name of the logical node plus the name of the data component, and then the property I want on that data object. And that makes this link here. In this test here, I have set the physical device object to use the notification. And so I have specified to Panorama that I want the buffered value, which means I'm using the BRCB, the buffered reporting control block in the RTU, to do the acquisition. So all of the elementary data have their link configured like this. So only by configuring my physical device name and putting the right name for my logical node, the IEC acquisition is completely ready. This logical node level component has a view that is built by assembling the elementary view of each data component. And I just have to embed this view into my main view here to have a ready-to-use application. So we can give it a go. Okay, so we can see here the analog input, which is changing when I turn the control here. So if I pass 10,000, I should get an alarm. Here I can play with the switches, and I can, like this, trigger the inputs and see the alarm triggered in Panorama. And now I'm going to play with the output, so that's binary outputs. But these binary outputs have been programmed by Brodersen to use a control model of the select before operate with enhanced security type. That's the most complex control model, which means that the Scada, and here I have decided that the user sees all the stages, the steps of passing a command. So the operator needs to first do a select, and with the enhanced security, he must select, specifying what is the intended command value. So here, for instance, I want to select for an on command. The select was successful, so it has enabled the operate button, so I can click on the operates, and the command has been accepted. And now I can do a select off, accepted, operate. And if I do a select on and a cancel, it actually sends to the RTU a cancel request. So that's the tag is now available for another workstation to do a select and an operate. Okay, let's have a look to another application just to illustrate that you can use all the different type of control models available in IEC with Panorama. We have here an application from one of our customers working in the field of wind farms. He has developed a circuit breaker component. And when the operator clicks on the circuit breaker, there is a check of what is the current control model used by that circuit breaker. And depending on the results of the control model configured in the RTU, it will open the right pop-up. So we have a pop-up for a type of control, a direct control. So that's just an open and close. And the cancel will just close the window, but there is no communication with the RTU. The direct control with enhanced security, it's the same pop-up for the operator, open, close, and the cancel just close the view. But after the close or the open has been sent to the RTU, the Panorama will check with the RTU if the operation was successful. The select before operate pop-up this time will show a select button for the operator. Once the select has been agreed by the RTU, because the variable is available for command because not already commanded by somebody, or because the process is in the right conditions to accept the command, then the operator can do a close or an open. But this time the cancel would send to the RTU the information that the select is cancelled. If you want to, if you change your mind, for instance, and you want to close the view before issuing the close or open command. And the control type select before operate with enhanced security, it's the one we just used in our test with the Brodersen PLC. You need to do a select with the information that you intend to send as a command, so open or close for this breaker. Then you set the operate, and Panorama will check that the operation completed successfully. And if you change your mind before operating, then you can use the cancel. That will also send the command to the PLC to cancel the select. So this is the support for control models by Panorama. But Panorama also supports other services from IEC 61850. We support, for instance, the date quality, which means that you don't not only receive from IEC a quality on the value of the information, but you also receive an information on the date quality. It gives you the date precision. Is it millisecond or is it microsecond? And if it's microsecond, of course, Panorama keeps the microseconds resolution of your date time, of your timestamp in the alarms and in the archives. The date quality also tells you if the RTU has any issue with time synchronization, for instance. And because it's the quality of the value, it means that even if it happens the day before, when you analyze some alarms or some trends, the quality will tell you if at that time the timestamp was accurate or not. So that's a very big benefit to have it in the quality of the tag and not just as a side information. Other kind of service that you can use through Panorama, it's the file upload and download. For instance, if you have in your RTU a function to very fast save information on fast changing values for perturbation on your electrical network, for instance, you can use Panorama to download this file into your workstations and then use specialized software to analyze those files. Okay, so that's all the kind of services you can use on IEC with Panorama. Okay, I think that's all for the demo today, and we'll switch back with Julien for the question and answer session.
So the end of the webinar is near, and we'd like you to tell you a short rehearsal of the presentation as a summary, as a conclusion. Niels?
What are the benefits of IEC 61850? Well, first of all, the interoperability. The IDs can now communicate with each other without any problems. And the standard was designed for the power industry. And with that in mind, it has some very useful features such as goose messages, which lowers the cost for hardwiring, but also sample measured values where you can get values directly from the sensors. But also the overall design philosophy where you can actually configure a complete system in one software tool and then extract the different parts directly to the Scada host, the IEDs, or an RTU. That really simplifies the implementation and commissioning, but of course also the maintenance benefits from that.
There are also owner energy components. You will meet 61850 and Panorama on traditional power productions and also on renewables with some time-specific needs. You may know that Panorama is a versatile and flexible tool. You will meet also it on high electricity consumption industries or buildings where the production is handled by the same Scada which deals with 61850 on the electricity consumption side. Like sometimes stadiums with their own power transformers. Most of you already know that Panorama is a versatile Scada tool. Building projects with it makes the Scada applications fit to the end user needs, the technical restrictions and opportunities, and to the integrator mindset and habits and already made components. So Panorama really suits the 61850 mindset, not only on the protocol side, but also on the object-oriented behavior, on the models and instances, the concepts, the openness, the import and export tools, etc. So finally, Panorama Squared is used as a power grid management system, which extends it to traditional Scada behaviors. Or in other way, the Panorama Squared is known as a versatile Scada software embedding 61850 features.